This screencast is on valence electrons, the atom's outermost electrons that are involved in bonding. Now we're going to start with carbon as an example. Carbon is atomic number 6. So recall that the atomic number tells us how many protons carbon has. So a carbon atom contains 6 protons because it's atomic number 6. And it also contains 6 electrons if it's neutral. So carbon, atomic number 6, 6 protons, 6 electrons if it's neutral. Let's draw a Bohr model to represent carbon. The dot in the center will be its nucleus with 6 protons, and it also has some neutrons. And then we'll put 2 electrons in the first energy shell for a Bohr model. But we need a total of 6 electrons, and that first shell is filled with 2 electrons. So we'll need 3, 4, 5, 6 total electrons for carbon's Bohr model. So here we've got carbon, and the 4 electrons in this outermost shell are carbon's valence electrons. So we'd say that carbon has 4 valence electrons. Even though carbon has 6 total electrons, only 4 of them are in the outermost shell and therefore are valence electrons, and so are therefore involved in chemical bonding. Carbon can't use those first 2 in bonding because they're already paired up and in a filled shell. Carbon can only use the outer 4 electrons, the valence electrons. Now, if we look at Bohr models for lots of elements on the periodic table, we can look at all of the elements that are in carbon's main group in the same column as carbon. If we study carbon and silicon and germanium, we see that they all have 4 outermost valence electrons in their Bohr model. We can look at each of the main groups on the periodic table. Going down the alkali metals, starting with hydrogen and lithium and sodium, they each have 1 valence electron. And in the alkaline earth metal column, they have 2 valence electrons. And if we keep moving down the main groups, we see 3 valence electrons, and 4, and 5, 6. If we go to the halogens, they all have 7 valence electrons. And the noble gases all have 8 valence electrons, or a filled outer valence shell, except helium that only needs a total of 2 electrons to fill its outermost valence shell. So there's a pattern on the periodic table here. So if we go back to our table, we have this pattern on our periodic table. We have the valence electrons printed right here for each of the main groups. So in the alkali metals, 1 valence electron. Alkaline earth metals all have 2 valence electrons going over and across the main groups, 3, 4, 5, 6, 7 valence electrons, and then in the last column, there are 8 valence electrons. So we can use an element's position in the periodic table to determine how many outermost valence electrons that element would have to be involved in chemical bonding.